transportation will leave you inspired. Let's unveil these innovations and discover how the future of travel is closer than you think. Electric vertical takeoff and landing aircraft. One of the most thrilling developments in transportation is the rise of electric vertical takeoff and landing aircraft, commonly known as eVTOLs. These vehicles, often referred to as flying cars, are poised to revolutionize urban mobility by combining the convenience of air travel with sustainable electric propulsion. Imagine soaring above traffic jams, reaching your destination in a fraction of the time it would take on the ground. eVTOLs are compact, electric-powered aircraft designed to take off and land vertically, much like helicopters, but without the need for runways. Equipped with multiple rotors or tilt-rotor systems, they offer efficient forward flight and hovering capabilities. Their electric propulsion systems make them quieter and more environmentally friendly than traditional aircraft, producing zero emissions during operation. The potential applications of eVTOLs are vast. In congested cities, they could drastically reduce travel times by allowing passengers to bypass traffic entirely. Companies like Joby Aviation and Archer Aviation are already testing prototypes aiming to launch aerial ride-sharing services that function much like Uber or Lyft, but in the sky. These services could transform daily commutes and even intercity travel, making them faster and more efficient. Safety and efficiency are at the forefront of eVTOL development. Advanced sensors and autonomous flight systems are being integrated to ensure safe navigation through urban airspaces. Additionally, the reduction in noise pollution compared to helicopters makes them more suitable for frequent use in populated areas. Despite the excitement, challenges remain. Battery technology needs to advance to extend the range and flight time of eVTOLs. Regulatory frameworks for low-altitude air traffic need to be established to ensure safety and coordination among multiple aircraft. However, with rapid advancements and significant investments pouring into this field, eVTOLs are not just a futuristic concept, they're becoming a reality. The skies of our cities may soon be buzzing with these innovative flying machines, heralding a new era of urban transportation. Hyperloop technology. Hyperloop technology stands as one of the most groundbreaking transportation innovations of the 21st century. Initially proposed by Elon Musk in 2013, the Hyperloop promises to revolutionize travel by combining elements of rail, air, and space technology. Imagine traveling between cities at speeds exceeding 700 miles per hour, cutting journey times from hours to mere minutes. At its core, the Hyperloop consists of pods or capsules that travel through low-pressure tubes. By eliminating nearly all air resistance and utilizing magnetic levitation, these pods can glide at incredible speeds. The absence of friction allows for energy-efficient travel, with some designs proposing the use of renewable energy sources like solar panels to power the system. The potential impact of Hyperloop is immense. Intercity travel could become faster than air travel without the associated emissions. For example, a trip from Los Angeles to San Francisco, which currently takes about 6 hours by car or 1 hour by plane, excluding airport procedures, could be reduced to just 30 minutes. This could dramatically reshape economies, making it feasible to live in one city and work in another far away. Several companies are racing to bring Hyperloop to reality. Virgin Hyperloop has conducted successful test runs, including the first passenger trials, demonstrating the safety and viability of the technology. Other companies like Hyperloop Transportation Technologies are also making significant strides, collaborating with governments worldwide to explore potential routes. However, challenges exist. Building the infrastructure requires substantial investment and engineering prowess. Safety concerns, such as emergency evacuations and structural integrity of the tubes, need thorough addressing. Regulatory frameworks must be developed to govern this new mode of transport. Despite these hurdles, the momentum behind Hyperloop technology is strong. With continued innovation and collaboration, we may soon witness a transportation revolution that redefines the speed and convenience of ground travel. Autonomous vehicles. Autonomous vehicles, or self-driving cars, are set to transform the way we think about transportation. Utilizing advanced sensors, artificial intelligence, and machine learning algorithms, these vehicles navigate roads and make real-time decisions without human intervention. Picture a future where traffic accidents are drastically reduced, commutes are less stressful, and mobility is accessible to all, including those unable to drive. The technology behind autonomous vehicles involves a combination of cameras, LiDAR, radar, and GPS systems, working in unison to create a detailed understanding of the vehicle's surroundings. Machine learning algorithms process this data to recognize patterns, predict movements of other road users, and make safe driving decisions. Companies like Waymo, Tesla, and General Motors are at the forefront of this innovation, conducting extensive testing and refining their autonomous systems. The benefits of AVs are significant. Safety is paramount. By eliminating human error, which accounts for the majority of traffic accidents, roads could become much safer. Autonomous vehicles can react faster than humans and are not subject to distractions or fatigue. They also have the potential to optimize traffic flow, reducing congestion through coordinated routing and speed adjustments. Moreover, AVs could revolutionize mobility for the elderly and disabled, providing independence to those who cannot drive themselves. Ride-sharing services could become more efficient and cost-effective, with fleets of autonomous vehicles available on demand. Challenges remain in the widespread adoption of AVs. Technical hurdles like navigating complex urban environments, adverse weather conditions, and unpredictable human behavior are areas of ongoing development. Regulatory and ethical considerations, such as liability in the event of an accident and data privacy, need comprehensive frameworks. Public trust is also crucial. People need assurance of the technology's safety and reliability. Despite these challenges, the progress is undeniable. Autonomous vehicles are already being tested on public roads in various cities worldwide. As technology advances and regulations evolve, the era of self-driving cars is not a distant dream, but an approaching reality that promises to reshape our transportation landscape profoundly. Maglev trains. Magnetic levitation, or maglev trains, represent a leap forward in high-speed rail technology. Utilizing powerful electromagnets, these trains hover above the tracks, eliminating friction and allowing for unprecedented speeds and smoothness. Imagine traveling between cities at over 300 miles per hour, with journeys that are not only faster, but also more comfortable and environmentally friendly. Maglev technology works by using opposing magnetic forces to lift and propel the train. The absence of physical contact between the train and the track reduces mechanical wear and energy loss due to friction. Countries like Japan and China have already implemented maglev trains, with China's Shanghai Maglev reaching speeds of up to 267 miles per hour, connecting the city to its airport in a matter of minutes. The benefits of maglev trains are manifold. They offer a high-speed alternative to air travel for medium-range distances without the associated carbon emissions. The smooth ride enhances passenger comfort, and the technology is remarkably energy efficient once the train is in motion. Maglev systems also have lower maintenance costs over time due to reduced mechanical wear. Challenges to widespread adoption include the high initial infrastructure costs and the need for specialized tracks incompatible with conventional rail lines. Building new routes requires significant investment and long-term planning. However, as demand for sustainable and efficient transportation grows, more countries are exploring maglev technology as a viable option. In the pursuit of reducing carbon footprints and improving transit efficiency, maglev trains stand out as a promising solution. As technology advances and costs decrease, we may see more of these high-speed marvels connecting cities and reshaping our perceptions of rail travel. Connected cars and IoT integration. The integration of the Internet of Things into vehicles is ushering in a new era of connectivity and smart transportation. Connected cars equipped with sensors, internet access, and advanced software can communicate with other vehicles, infrastructure, and even pedestrians. This connectivity enhances safety, optimizes traffic flow, and provides a more personalized driving experience. Connected cars utilize technologies like vehicle-to-vehicle and vehicle-to-infrastructure communication to share real-time information. For instance, a car can receive data about traffic congestion ahead, adjust its route accordingly, or even communicate with traffic lights to optimize speed and reduce stops. This level of coordination can significantly reduce accidents and improve fuel efficiency. The benefits extend to enhanced infotainment systems, over-the-air updates, and predictive maintenance alerts. Drivers can enjoy seamless integration with their devices, access cloud-based services, and receive software updates without visiting a service center. Predictive maintenance can alert owners to potential issues before they become serious, reducing downtime and repair costs. However, the rise of connected cars brings challenges, particularly concerning cybersecurity and data privacy. Protecting vehicles from hacking attempts and ensuring the secure handling of personal data are paramount. Manufacturers and regulators are working together to establish standards and protocols to address these concerns. As 5G networks expand, the capabilities of connected cars will grow exponentially. Faster data transmission will enable more complex interactions and support the development of autonomous driving features. The fusion of connectivity and transportation heralds a future where cars are not just vehicles but integrated components of a broader, intelligent transportation ecosystem. Micromobility solutions. Micromobility solutions, including electric scooters, bicycles, and compact electric vehicles, are transforming urban transportation. Designed for short-distance travel, these options offer affordable, eco-friendly alternatives to traditional cars and public transit. Imagine zipping through city streets on an electric scooter, bypassing traffic, and reaching your destination efficiently. The rise of shared micromobility services has made these options widely accessible. Companies like Lime, Bird, and Jump provide app-based rentals, allowing users to locate and unlock vehicles with their smartphones. These services cater to the last-mile problem, bridging the gap between public transit stops and final destinations. Micro-mobility offers several benefits. It reduces traffic congestion by taking cars off the road, lowers emissions, and provides flexible transportation options tailored to individual needs. For cities grappling with pollution and overcrowded streets, encouraging micromobility can be a significant part of the solution. Challenges include regulatory hurdles, safety concerns, and infrastructure needs. Cities must develop policies to manage the proliferation of shared devices, ensure they are used responsibly, and integrate them into existing transportation networks. Building dedicated lanes and parking areas can enhance safety for both riders and pedestrians. As urban areas continue to grow, micromobility is poised to play an essential role in creating sustainable, livable cities. By embracing these small but impactful transportation options, we can move toward a future where mobility is accessible, efficient, and environmentally friendly. Smart roads and infrastructure. The future of transportation isn't just about vehicles. It's also about the roads we travel on. Smart roads equipped with sensors, connectivity, and innovative materials are set to transform infrastructure. Envision highways that can communicate with your car, alerting you to hazards ahead, adjusting traffic flow, and even generating energy. Smart roads incorporate technologies like embedded sensors to monitor traffic conditions, weather, and structural integrity. They can relay real-time information to connected vehicles, enhancing safety and efficiency. For example, sensors can detect ice forming on the surface and warn approaching drivers or activate heating elements to melt it. Some smart road concepts include dynamic lane markings that adjust during peak hours, solar panels integrated into the pavement to generate electricity, and induction coils that wirelessly charge electric vehicles as they drive. These innovations can reduce reliance on external energy sources and support the growing number of electric vehicles. Implementing smart infrastructure faces challenges such as high initial costs, maintenance requirements, and the need for standardization across regions. However, the long-term benefits of reduced accidents, improved traffic management, and sustainable energy generation make it a compelling investment. As cities and countries invest in upgrading infrastructure, smart roads represent a significant step toward a more connected and efficient transportation network. By transforming passive pavement into active components of the transportation ecosystem, we're paving the way for a smarter, safer future on the road. As we've explored, the future of transportation is filled with incredible innovations set to reshape our world. If you enjoyed this exploration into the future of transportation, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the wonders of our evolving world with us.
What if the secrets to life on Earth could help us uncover the existence of life in the vast expanse of space? Could alien organisms be living in extreme environments like those found in our own oceans? And what if planets we thought uninhabitable were teeming with microbial life? Join us as we explore 7 mind-blowing concepts in astrobiology that challenge everything we thought we knew about the universe and the possibility of life beyond our planet. The origins of life, how it all began. Astrobiology begins with one of humanity's oldest questions: how did life begin? Understanding the origins of life on Earth is key to determining where and how life might exist elsewhere in the universe. Scientists hypothesize that life on Earth originated around 3.5 to 4 billion years ago in an environment much harsher than the one we live in today. Theories such as the primordial soup model suggest that life began from simple organic molecules forming in Earth's early oceans. However, there's also the deep-sea hydrothermal vent hypothesis, which proposes that life started in the extreme environments of deep ocean hydrothermal vents. These vents host life forms that thrive without sunlight, raising the question, could similar environments on other planets or moons host life? The origins of life debate don't stop at Earth. Astrobiologists are looking at places like Mars and Jupiter's moon Europa, where conditions may have mirrored early Earth. Organic compounds considered the building blocks of life have already been detected on these worlds, sparking curiosity about whether life ever arose or still exists there. The discovery of extremophiles on Earth, organisms that live in seemingly uninhabitable places like volcanic vents and acidic lakes, has broadened the scope of astrobiological research. If life can thrive in such conditions on Earth, where else could it exist? But what if life didn't start on Earth at all? The panspermia theory suggests that life could have originated elsewhere in the cosmos and been transported to Earth via comets or meteorites. This possibility means that the origins of life might be a universal phenomenon, not just a terrestrial one. By understanding how life began on Earth, astrobiologists hope to unlock the mysteries of life's potential beginnings elsewhere. Ultimately, the search for the origins of life isn't just about looking backward, it's about searching forward to other planets, moons, and even exoplanets, in hopes of discovering the same cosmic recipe that gave rise to life on Earth. Habitable zones, the Goldilocks principle in action. In astrobiology, the search for life starts with identifying where it could possibly thrive. The concept of the habitable zone, often called the Goldilocks zone, refers to the region around a star where conditions are just right for liquid water to exist. Without liquid water, life as we know it could not exist. Planets within this zone aren't too hot or too cold, making them prime candidates in the search for extraterrestrial life. However, recent discoveries have challenged the traditional definition of habitability. While liquid water is a key ingredient for life, we are learning that life might exist in extreme conditions far outside our initial expectations. For instance, Saturn's moon Enceladus and Jupiter's moon Europa are both well outside the traditional habitable zone. Yet, beneath their icy crusts, scientists believe vast oceans of liquid water exist. With geysers shooting water vapor from Europa's surface, it's become one of the most exciting places to search for extraterrestrial life in our solar system. Beyond our solar system, thousands of exoplanets, planets orbiting stars outside of our solar system, have been discovered, and many reside within their stars' habitable zones. NASA's Kepler mission has confirmed the existence of planets in these zones, leading scientists to speculate about the possibility of life on these distant worlds. But could life exist in ways that don't depend on water at all? Some astrobiologists argue that life on other planets might use chemicals or elements different from the ones we know to support biological processes. This evolving understanding of habitable zones underscores a central tenet of astrobiology. We must keep expanding our definitions and expectations if we hope to find life beyond Earth. The Goldilocks principle, though useful, is just the beginning of our cosmic search. Extremophiles, life in the unlikeliest places. One of the most mind-boggling concepts in astrobiology is the study of extremophiles, organisms that thrive in conditions that would be lethal to most other life forms. These hardy creatures survive in the most extreme environments on Earth, from scalding hydrothermal vents deep in the ocean to the frozen deserts of Antarctica and even within radioactive waste. Studying extremophiles is crucial to astrobiology because they show us that life can exist in conditions far beyond what was once thought possible. Extremophiles are divided into several categories depending on their environments. Thermophiles live in extreme heat, Acidophiles in highly acidic environments, and halophiles thrive in places with extremely high salt concentrations. Some extremophiles even survive in the vacuum of space. Understanding how these organisms manage to survive, and even thrive, could be the key to understanding how life might exist on planets and moons with harsh environments like Mars or the icy moons of Saturn and Jupiter. Astrobiologists are especially interested in extremophiles because they represent living proof that life can find a way under seemingly impossible conditions. On Earth, extremophiles are found in places that mirror the environments of other planets. The cold, dry deserts of Antarctica resemble the surface of Mars, while the hydrothermal vents deep in Earth's oceans mimic what might exist under the ice crusts of Europa or Enceladus. If life can thrive in these earthly extremes, it's possible similar life forms could exist in the outer reaches of the solar system and beyond. These findings don't just apply to our solar system. When we look at exoplanets orbiting distant stars, the presence of extremophiles suggests we shouldn't be too quick to dismiss worlds that seem inhospitable at first glance. With every new discovery, we're learning that life is far more adaptable and resilient than we ever imagined. And the study of extremophiles opens up possibilities that are truly out of this world. Panspermia. Did life travel to Earth from space? One of the most intriguing ideas in astrobiology is the theory of panspermia, which suggests that life didn't actually start on Earth but was instead carried here from somewhere else in space. According to this theory, microbial life could have hitched a ride on comets, asteroids, or even cosmic dust, arriving on Earth billions of years ago. This idea challenges the notion that Earth is unique as the birthplace of life and instead opens the possibility that life could be a cosmic phenomenon, with planets like ours acting as receivers. The panspermia theory has gained traction as scientists discover more about the resilience of life, particularly extremophiles. Some microorganisms are capable of surviving the vacuum of space, intense radiation, and extreme cold or heat. If life can endure space travel, even in microbial form, it's not hard to imagine how life from other planets or moons could have arrived on Earth through impacts with space debris. For instance, the discovery of organic molecules on comets and meteorites adds to the evidence that life's ingredients, or perhaps even life itself, could travel between planets. Additionally, panspermia introduces the possibility that life could be widespread across the galaxy, hopping from one planetary system to another. If microbial life can survive the journey across space, it's possible that Earth isn't the only planet to have received such visitors. Mars, which scientists believe once had flowing water and a more Earth-like climate, could have been one such planet. In fact, some speculate that life on Earth might have originated on Mars before migrating here. While panspermia remains a hypothesis, it expands our perspective on life's origins and where we should search for it. If life can travel between celestial bodies, then the universe may be teeming with life, with each planetary system passing the torch of life to its neighbors. As we continue to explore the solar system and beyond, astrobiologists are on the lookout for signs that panspermia may be more than just a theory. Biosignatures, the clues that could reveal alien life. A key part of the search for extraterrestrial life involves the hunt for biosignatures, indicators that life, as we know it, either exists or once existed in an environment. Biosignatures can take many forms, from specific gases in a planet's atmosphere to the presence of complex organic molecules. The discovery of biosignatures would be one of the biggest breakthroughs in astrobiology, offering tangible proof that life exists beyond Earth. One of the most promising biosignatures is the detection of methane on Mars. Methane can be produced by geological processes, but it's also a byproduct of biological activity. The presence of fluctuating methane levels on the red planet has led scientists to speculate that there could be microbial life beneath the surface. In 2020, NASA's Curiosity rover detected seasonal methane spikes on Mars, reigniting interest in the planet as a potential host for life. While methane alone isn't definitive proof of life, it's a strong biosignature that warrants further investigation. Beyond Mars, biosignature detection plays a crucial role in the study of exoplanets. NASA's James Webb Space Telescope and other upcoming missions aim to study the atmospheres of distant planets, searching for gases like oxygen, methane, and carbon dioxide, chemical fingerprints of potential life. One of the most exciting discoveries in recent years was the detection of phosphine gas in the atmosphere of Venus. On Earth, phosphine is primarily produced by biological processes, leading to speculation that microbial life could exist in the planet's acidic clouds. The search for biosignatures is an ongoing complex process, as many signals could have non-biological origins. But the detection of even one unambiguous biosignature would revolutionize our understanding of the universe and our place in it. As technology advances and our understanding of life deepens, the chances of detecting biosignatures beyond Earth are becoming increasingly likely. The Fermi paradox. Where is everybody? With the vast number of stars and planets in the universe, many scientists believe that intelligent extraterrestrial life should be common. So why haven't we encountered it yet? This question is known as the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" when considering the likelihood of intelligent alien civilizations. The Fermi paradox points out the contradiction between the high probability of life existing elsewhere in the universe and the complete absence of evidence for it. One possible solution to the paradox is that intelligent civilizations are rare, either because life rarely evolves to the point of intelligence, or because such civilizations tend to self-destruct before they can explore the stars. The history of Earth shows that complex, intelligent life took billions of years to develop, and human civilization has only existed for a tiny fraction of that time. It's possible that intelligent life on other planets may be in an earlier or later stage of evolution than we are. Another explanation is that advanced civilizations are out there but deliberately avoiding contact. This idea, sometimes called the Great Silence, suggests that alien civilizations might have their own reasons for staying hidden, such as not wanting to interfere with less advanced species like ours. Alternatively, they might communicate in ways we haven't yet discovered, using technology or signals that we are incapable of detecting with our current methods. Finally, there's the possibility that the distances between stars and galaxies are simply too vast for civilizations to communicate or travel across in any meaningful way. Even if alien civilizations exist, they could be so far away that we may never encounter them. As we continue to explore space and search for extraterrestrial life, the Fermi paradox remains one of the greatest mysteries in science. The search for exoplanets worlds beyond our solar system. In the past few decades, one of the most exciting developments in astrobiology has been the discovery of exoplanets, planets that orbit stars outside our solar system. These worlds, once only a figment of science fiction, have become the focal point of our search for life beyond Earth. As of 2024, astronomers have confirmed the existence of over 5,000 exoplanets, many of which reside in their star's habitable zone. One of the most famous discoveries is Kepler 186f, an Earth-sized planet located in the habitable zone of its star. This discovery, made by NASA's Kepler mission, was a milestone in the search for potentially life-supporting planets. Exoplanets like Kepler 186f are of particular interest because they could have the right conditions for liquid water, an essential ingredient for life as we know it. The sheer diversity of exoplanets, ranging from gas giants to rocky Earth-like planets, suggests that there are likely many more yet to be discovered, some of which may host alien life. The tools used to discover exoplanets, such as the transit method and radial velocity method, have revolutionized our understanding of the universe. The upcoming James Webb Space Telescope and other next-generation observatories will be able to probe the atmospheres of these distant worlds, searching for biosignatures and signs of habitability. This technological leap could bring us closer than ever to answering the age-old question, are we alone in the universe? The discovery of exoplanets has expanded our horizons, showing us that planetary systems are common throughout the galaxy. As we continue to explore, the potential for finding life in one of these distant worlds grows with each discovery. Whether or not we find life on these exoplanets, their existence challenges us to imagine the possibilities of life beyond our solar system. As we delve deeper into astrobiology, one thing becomes clear: the universe is full of surprises. From the possibility of life in extreme environments to the discovery of habitable zones beyond our expectations, astrobiology constantly pushes the boundaries of what we think is possible. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us. In a world where sustainability is no longer optional, buildings are transforming into smart, eco-friendly hubs of efficiency. But what are the technologies driving this green revolution? How can we reduce energy consumption while maintaining comfort and convenience in modern infrastructure? If you've ever wondered what the future of energy-efficient buildings looks like, you're in the right place. Join us as we explore 7 game-changing innovations that are reshaping the way we design and manage buildings for a greener tomorrow. So sit tight and join us on this exciting journey into the future of sustainable architecture. Advanced glazing systems. Windows are often the weak link in a building's energy efficiency. Traditional windows allow heat loss during winter and excessive heat gain in summer, increasing energy usage for heating and cooling. Advanced glazing systems, however, are transforming this by using innovative materials and technologies to improve insulation and energy performance significantly. These systems feature multiple glass layers, often filled with inert gases like argon or krypton, which help reduce heat transfer while still allowing natural light to enter. One exciting development in advanced glazing is electrochromic glass, a smart glass that changes tint based on external conditions, like sunlight and temperature. This feature allows the building to regulate heat gain and loss without relying heavily on HVAC systems. On hot sunny days, the glass darkens to reduce solar heat gain, and on cold days it stays clear to allow warmth inside. This dynamic behavior is ideal for reducing energy consumption while maintaining occupant comfort year-round. Beyond temperature regulation, advanced glazing also tackles glare and UV exposure, which affect indoor comfort. With special coatings that block harmful UV rays, these systems protect interiors from fading and reduce the need for artificial lighting, which further lowers energy usage. By minimizing glare, these windows enhance visual comfort, making spaces more usable without extra lighting or blinds. Installing advanced glazing in new buildings or retrofitting existing windows is a straightforward way to boost energy efficiency. While the initial costs may be higher, the long-term benefits, such as energy savings, increased comfort, and reduced HVAC loads, make them a wise investment. Over time, these systems can substantially lower a building's carbon footprint and save on energy bills, establishing them as a vital component of sustainable architecture. Building automation systems. Building automation systems, or BAS, are transforming energy management in modern buildings by integrating and automating functions like heating, ventilation, air conditioning, lighting, and security. Acting as a central hub, BAS optimizes these operations to maximize energy efficiency without compromising comfort. Using real-time data from sensors, BAS adjusts systems based on occupancy, time of day, and outdoor temperature to minimize waste and reduce energy costs. A major advantage of BAS is its ability to offer real-time monitoring and control. Operators can track energy usage across systems and make adjustments through a single interface, improving decision-making for energy management. For instance, BAS can automatically dim lights or adjust HVAC settings when rooms are unoccupied, leading to substantial energy savings over time, especially in large buildings. With advancements in cloud technology and AI, BAS has become even more powerful. Cloud capabilities allow remote access to multiple properties, while AI enables predictive management, anticipating patterns like peak occupancy and seasonal changes. AI-driven BAS can also detect potential equipment issues early, allowing for proactive maintenance and further energy savings. BAS not only improves energy efficiency but also enhances building performance and comfort. By automating and optimizing key systems, BAS creates a comfortable environment while reducing operational costs. Scalable for various building sizes, BAS is becoming essential for sustainable building design as energy costs rise and the need for greener solutions grows. Green roofs and cool roofs. Roofing plays a key role in building energy efficiency by affecting heat exchange. Green roofs and cool roofs are two innovative options that help reduce the impact of the sun's heat. Green roofs covered with vegetation provide natural insulation, keeping buildings cooler in summer and warmer in winter. These living roofs also support urban environments by enhancing biodiversity and reducing the urban heat island effect, where city temperatures rise due to concrete and asphalt. Cool roofs, in contrast, use highly reflective materials to deflect sunlight and absorb less heat. By reflecting solar radiation, these roofs lower indoor temperatures and reduce the need for air conditioning, making them especially effective in warm climates. Simple and versatile, cool roofs can be applied to both new and existing buildings, offering a cost-effective solution for energy efficiency. Both roof types lead to energy savings during extreme weather. Green roofs insulate, cutting heating and cooling costs, while cool roofs reduce heat buildup, lessening the demand for air conditioning. These savings are particularly valuable in urban areas where energy use drives pollution and greenhouse gas emissions. Additionally, green roofs extend roof lifespans by protecting materials from harsh weather. Beyond energy efficiency, green roofs offer ecological benefits. They absorb rainwater, cut stormwater runoff, and improve air quality by filtering pollutants. While cool roofs may not have the same ecological impact, they still help reduce energy demand and lower carbon footprints. Whether through lush vegetation or reflective surfaces, green and cool roofs play a crucial role in building a more sustainable future. Energy-efficient HVAC systems. Heating, ventilation, and air conditioning systems are crucial for indoor comfort, but are also among the biggest energy consumers, often accounting for up to 40% of a building's total energy use. Energy-efficient HVAC systems tackle this by optimizing how they heat, cool, and ventilate spaces, reducing energy consumption without sacrificing comfort. Technologies like variable refrigerant flow, smart thermostats, and geothermal heat pumps are central to this efficiency improvement. Variable refrigerant flow systems are a game changer, as they adjust refrigerant flow based on real-time demand across different zones. This allows precise temperature control, heating or cooling only occupied areas, which significantly reduces energy use, particularly valuable in large buildings with varying occupancy, like offices and hotels. Geothermal heat pumps are another advanced solution, utilizing the Earth's stable underground temperatures for heating and cooling. By transferring heat from the ground in winter and dissipating heat back in summer, geothermal systems can cut energy usage by up to 50%. While they have a higher installation cost, their long-term energy savings and low maintenance requirements make them an attractive option for sustainability-focused building owners. The integration of smart thermostats and sensors enhances HVAC efficiency by learning usage patterns and automatically adjusting settings based on occupancy, humidity, and air quality. This real-time optimization ensures that energy isn't wasted in unoccupied spaces, further reducing costs and improving indoor air quality. Together, these advancements are transforming HVAC systems from energy-intensive necessities into sustainable, intelligent solutions that help lower energy bills, reduce carbon footprints, and create healthier indoor environments. Smart lighting systems. Lighting accounts for a significant portion of energy consumption in buildings, but smart lighting systems are revolutionizing how this energy is managed. By using advanced technologies like LED bulbs, sensors, and automated controls, smart lighting ensures that energy is only used when needed, enhancing both efficiency and comfort by adjusting lighting based on occupancy, natural light levels, or user preferences. LED bulbs are essential to these systems, using up to 75% less energy and lasting up to 25 times longer than traditional bulbs, which also reduces maintenance costs. Paired with motion sensors and timers, smart lighting activates only when someone is present, minimizing unnecessary energy use and providing substantial savings over time. Occupancy sensors play a crucial role, especially in spaces like offices, conference rooms, and restrooms, where lights are often left on when not in use. These sensors automatically switch lights off when rooms are vacant, while daylight sensors adjust indoor lighting according to the natural light available, further reducing energy consumption and enhancing the indoor environment. Smart lighting systems can also integrate with building automation systems, or BAS, for centralized control over the entire building's lighting. This allows remote adjustments and optimization across multiple areas, maximizing efficiency. Additionally, these systems offer personalized control through mobile apps or voice commands, enabling users to customize brightness, color, and schedules to suit their needs. This combination of energy savings, user convenience, and enhanced comfort makes smart lighting an invaluable tool for creating energy-efficient, adaptable, and sustainable indoor spaces. As more buildings incorporate smart technologies, smart lighting will continue to play a vital role in the shift toward greener buildings and reduced energy footprints. Solar panels with energy storage. Solar panels are a powerful renewable energy source helping to reduce reliance on fossil fuels, but their full potential is realized with energy storage systems. Solar panels capture energy from the sun during daylight, but without storage, this energy must be used immediately or is lost when the sun isn't shining. By pairing solar panels with advanced storage technologies, buildings can now save excess energy generated during the day for use at night or on cloudy days, providing a consistent and reliable energy supply. A key advancement in this area is lithium-ion battery technology, which efficiently stores large amounts of solar energy. These batteries allow buildings to store surplus power and use it during peak demand hours when electricity rates are higher. This reduces reliance on the grid, cuts electricity costs, and provides backup power during outages, keeping essential systems running smoothly. For both commercial and residential buildings, combining solar panels with energy storage offers significant environmental and financial benefits. By reducing dependency on traditional power sources, buildings can lower their carbon footprint while saving on energy bills. Additionally, as many regions offer incentives for renewable energy use, buildings with solar and storage systems may qualify for tax credits, rebates, or other benefits, making the investment more appealing. Emerging battery technologies like solid-state and flow batteries are further enhancing energy storage efficiency. These next-generation batteries offer longer lifespans, faster charging, and greater capacity, enabling buildings to store more solar energy for extended periods. As battery technology advances, solar energy systems will become even more cost-effective and accessible. This integration of solar power and storage is a major step toward energy independence and sustainability, making it a crucial component of energy-efficient building design for the future. Net zero building designs. Net zero buildings aim to balance energy consumption with on-site production, setting a high standard for sustainability and energy efficiency. By combining energy-saving features with renewable sources like solar panels and geothermal systems, these buildings minimize their carbon footprint and move toward energy independence. The key to achieving net zero status is reducing energy demand. Smart architectural designs make the most of natural resources. Passive solar design, strategic window placement, and building orientation maximize natural light and heat. High-performance insulation and airtight construction also play a critical role by reducing heat loss and lowering climate control needs. Efficient HVAC systems and LED lighting further decrease overall energy use. With energy demands minimized, renewable energy sources meet the remaining needs. Solar panels are a common choice, converting sunlight into electricity, while geothermal systems provide efficient heating and cooling. Energy storage solutions like lithium-ion batteries store excess energy for use at night or during low production periods, ensuring a steady energy supply and reducing grid dependence. Net zero buildings also offer financial benefits. They significantly lower utility bills and may qualify for tax incentives or rebates, offsetting initial costs. Additionally, as energy prices rise, these buildings provide financial stability by reducing reliance on traditional power sources. As more sustainable technologies become available, net zero buildings are paving the way for greener architecture, playing a vital role in shaping a more sustainable and energy-efficient future. As we conclude our exploration of these transformative technologies, it's clear that the future of energy-efficient buildings is not just about reducing costs, but creating a sustainable world for future generations. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us.
The future of transportation is evolving faster than ever before. From flying taxis to hyperloops, we're on the cusp of a revolution that will redefine how we move. Imagine cutting your daily commute in half or traveling between cities at speeds once reserved for airplanes. Are you ready to explore the next generation of groundbreaking transportation technologies? Join us as we dive into 7 futuristic innovations set to change our world. Whether you're a tech enthusiast or just curious about what's next, this journey into the future of transportation will leave you inspired. Let's unveil these innovations and discover how the future of travel is closer than you think. Electric vertical takeoff and landing aircraft. One of the most thrilling developments in transportation is the rise of electric vertical takeoff and landing aircraft, commonly known as eVTOLs. These vehicles, often referred to as flying cars, are poised to revolutionize urban mobility by combining the convenience of air travel with sustainable electric propulsion. Imagine soaring above traffic jams, reaching your destination in a fraction of the time it would take on the ground. eVTOLs are compact, electric-powered aircraft designed to take off and land vertically, much like helicopters, but without the need for runways. Equipped with multiple rotors or tilt-rotor systems, they offer efficient forward flight and hovering capabilities. Their electric propulsion systems make them quieter and more environmentally friendly than traditional aircraft, producing zero emissions during operation. The potential applications of eVTOLs are vast. In congested cities, they could drastically reduce travel times by allowing passengers to bypass traffic entirely. Companies like Joby Aviation and Archer Aviation are already testing prototypes aiming to launch aerial ride-sharing services that function much like Uber or Lyft, but in the sky. These services could transform daily commutes and even intercity travel, making them faster and more efficient. Safety and efficiency are at the forefront of eVTOL development. Advanced sensors and autonomous flight systems are being integrated to ensure safe navigation through urban airspaces. Additionally, the reduction in noise pollution compared to helicopters makes them more suitable for frequent use in populated areas. Despite the excitement, challenges remain. Battery technology needs to advance to extend the range and flight time of eVTOLs. Regulatory frameworks for low-altitude air traffic need to be established to ensure safety and coordination among multiple aircraft. However, with rapid advancements and significant investments pouring into this field, eVTOLs are not just a futuristic concept, they're becoming a reality. The skies of our cities may soon be buzzing with these innovative flying machines, heralding a new era of urban transportation. Hyperloop technology. Hyperloop technology stands as one of the most groundbreaking transportation innovations of the 21st century. Initially proposed by Elon Musk in 2013, the Hyperloop promises to revolutionize travel by combining elements of rail, air, and space technology. Imagine traveling between cities at speeds exceeding 700 miles per hour, cutting journey times from hours to mere minutes. At its core, the Hyperloop consists of pods or capsules that travel through low-pressure tubes. By eliminating nearly all air resistance and utilizing magnetic levitation, these pods can glide at incredible speeds. The absence of friction allows for energy-efficient travel, with some designs proposing the use of renewable energy sources like solar panels to power the system. The potential impact of Hyperloop is immense. Intercity travel could become faster than air travel without the associated emissions. For example, a trip from Los Angeles to San Francisco, which currently takes about 6 hours by car or 1 hour by plane, excluding airport procedures, could be reduced to just 30 minutes. This could dramatically reshape economies, making it feasible to live in one city and work in another far away. Several companies are racing to bring Hyperloop to reality. Virgin Hyperloop has conducted successful test runs, including the first passenger trials, demonstrating the safety and viability of the technology. Other companies like Hyperloop Transportation Technologies are also making significant strides, collaborating with governments worldwide to explore potential routes. However, challenges exist. Building the infrastructure requires substantial investment and engineering prowess. Safety concerns, such as emergency evacuations and structural integrity of the tubes, need thorough addressing. Regulatory frameworks must be developed to govern this new mode of transport. Despite these hurdles, the momentum behind Hyperloop technology is strong. With continued innovation and collaboration, we may soon witness a transportation revolution that redefines the speed and convenience of ground travel. Autonomous vehicles. Autonomous vehicles, or self-driving cars, are set to transform the way we think about transportation. Utilizing advanced sensors, artificial intelligence, and machine learning algorithms, these vehicles navigate roads and make real-time decisions without human intervention. Picture a future where traffic accidents are drastically reduced, commutes are less stressful, and mobility is accessible to all, including those unable to drive. The technology behind autonomous vehicles involves a combination of cameras, LiDAR, radar, and GPS systems, working in unison to create a detailed understanding of the vehicle's surroundings. Machine learning algorithms process this data to recognize patterns, predict movements of other road users, and make safe driving decisions. Companies like Waymo, Tesla, and General Motors are at the forefront of this innovation, conducting extensive testing and refining their autonomous systems. The benefits of AVs are significant. Safety is paramount. By eliminating human error, which accounts for the majority of traffic accidents, roads could become much safer. Autonomous vehicles can react faster than humans and are not subject to distractions or fatigue. They also have the potential to optimize traffic flow, reducing congestion through coordinated routing and speed adjustments.